So in this question, what we have is we have to give the answers in one decimal place. Okay, so we have that. So Roman number 1 would be 7 sine 2 theta. How about we divide it by cos 2 theta will be 5 cos 2 theta divided by cos 2 theta. So we know they will cut each other. So what I would have is tan 2 theta equals 5 divided by 2. So 2 theta is tan inverse of 5 divided by 2. So whenever we have such a thing, what you're going to get is the principal angle. So once you get the principal angles, that would be 35.3 degrees. So once we have it, it's answer for a one decimal place, so I'll keep the principal value as it is. This is the principal angle, and you know in the quadrants, in the 4 quadrants of this is positive, and here the tan is positive. Okay, so we know the two options are, one is 35.3. so in these quadrants, if I really quickly name what they are, is going to be, if this is, I'll not use this theta since it's in the equation. If this is x, this will be pi minus x, this will be pi plus x, and this will be 2 pi minus x. So the two answers that we have is, if I talk about in radians, that's going to be positive is 180 plus 35.3. So what are the values that we have is this and combination of this. These are the values. So okay, now then we know the tan theta repeats in every 180 degrees, but if we go to the range, so they have given us theta is in between 0 to 180, so we can say theta is between 0 to 180, so 2 theta is between 0 to 360. So if we really go beyond that, it doesn't give a correct answer, but as of now, with the two equations that we found, both are correct. So according to that, since the 2 theta is this, theta will be half of this, which is 35.5 degrees divided by 2. Here is 215.5 divided by 2. So theta here is going to be 17.8 degrees. Here theta is going to be 107.8 degrees. So these are the two answers coming for the first value. Okay, now let's go to the second part of the question. So I'll quickly take it to the next page. 0 to x and equals to then 2 pi. Okay, so we have these equations. Now it's 24 tan x equals 5x. 24 tan x equals 5 cos x. Okay, in this one, so if we really see, we have to go for a one trigonometric ratio only. So I'm going to write tan x in the way of sin x divided by cos x. So we have 5 cos x. Then I can multiply the whole thing by that. So then I have this side sin x. When I multiply the cos x, it will cut off. So this will be cos squared x. We know we can write the cos squared in the form of, because we know according to the normal theories 1 equals cos squared x plus sin squared x. Here we can subject the cos squared x, so here we can write 1 minus sin squared x. So I'm going to keep it like this so that I will have the everything in sin x. Okay, so if I remove the brackets and take it to this side, it will be sin 5 squared x plus 24 sin x minus 5 equals 0. So we can take it as our t as the sin x. So we have 5t squared plus 24t minus 5 equals 0. So once we get it, we can see the factorization, but it would have is 1 gonna be 5x minus 1, not x, I'm like, it's 5t minus 1. Other one would gonna be t plus 5 equals 0. So according to the two options, I'll just use this space. One option is t is 1 divided by 5. Other option is t is negative 5. We know this can't be that because sine theta, because our t is sin x. So this is the value that we had. So since because of that, we can't have a t value as a negative 5. So this answer is not given. So if you get the sin x, that's between this to 6. So that answer is not there. So we know sin x equals 1 over 5. So according to that, we have x is sine inverse 1 over 5. Whenever you have the sine over 1 over 5, we know that's a positive value. If we think about the quadrants, out of these quadrants, this is positive and this is sine, tan, cos. Sorry, here we just need the sine only. Sine positive is in these two quadrants. So this is the principal angle. So if we go to the principal angle, that's the sine inverse value in radians, which is 0.201. So the one mass is going to be the normal one. X is going to be 0.201. And another x is going to be pi minus 0.201, which is going to be 2.941. Yeah, these are the values that we can get. So let's check whether they have given us a range. Yeah, there's a range which is between 2 pi to 0. So yeah, we got correct answers now. Thank you.